This video tutorial is a follow-on from the first part of the gear example tutorial, where in the first video we calculated all the relevant dimensions in order to draw the representations of our gears. In this video we will complete the rest of the required steps to complete this question. So what was required was to complete the missing data in the table, which was completed in the last video. Then to complete the detail for the teeth of the gear. Remember that the teeth of the gear are not fully represented, only the root, pitch, and outside diameters are shown. And it also then says that assuming the meshing pinion gear is aligned with the vertical center line, so that's our center line A here. So we have both our pinion and our gear center on that vertical center line. We need to draw both the pinion and the gear, and the scale that we're going to be using for this drawing is the same as the gear ratio that's been given for the gears. So we're going to be drawing this to half scale. So our drawing will be half the size of the given dimensions. So all of these dimensions must be divided by 2. Then lastly, we need to draw the sectional side view of the main gear about the sectioning line AA, and it tells us that both gears, so that's both the pinion as well as the main gear, have a thickness of 20 millimeters. Okay, so we'll start by representing the outside diameter. The outside diameter we calculated in the previous video to be 177.66 millimeters. We'll need to divide this value by 2 for our scale, and then we divide it by 2 again to represent the radius. So the scaled outer radius will then be 44.4 millimeters. The reason we calculate this radius is because we need the radius to determine what the spacing between our compass points needs to be. So we'll measure that 44.4. I'm going to start at 10 and move to 4.4. And we then position the sharp point of our compass on the center of the gear, and we draw a broken dotted line to represent our outside diameter. And once our outer diameter has been drawn in, we then look at the pitch diameter. So again, the pitch diameter that we calculated in the previous video for our gear was 169.2 millimeters. We're then going to divide that by 4. Remember, we're dividing by 2 because of our scale, and then we're dividing by 2 again to get the radius. And then we get the radius that we need to set the distance of our compass points at to be 42.3 millimeters. We then do the same thing where we need to measure out that 42.3, and we then begin to draw in the lines for our pitch circle diameter. We then continue with the same process to calculate what the root diameter would be. So we have our 158.62 calculated in the previous video, and divide that by 4. When we divide our 158.62 by 4, we end up with 39.7. We then measure that out on our compass. Almost 14, and we then start to draw in the detail lines for our root diameter. Now that we've completed all of the relevant diameters to represent our gear teeth, we'll start on the sectioned side view through section AA. So we have our section line over here, and we're going to be cutting away this half of the gear and looking at it from that side. So we're going to see this face through the center of our gear. As far as completing the sectional side view, we will start by drawing the outline of the gear, so it would just be a rectangle similar to what's shown in the side view with hidden detail. We have been told that the thickness of the gear as well as the pinion is 20 millimeters, but we are drawing to a half scale, so we'll have a thickness of 10 millimeters. I've already projected across the top and bottom of the gear, so we'll just draw in a line that will act as our base, and we'll measure our 10 millimeters across from that, make a mark using our set square and our set ruler. We'll just draw in the other side of our gear. We can then fill in the outline of our gear and begin to fill in these inner detail. Now for the inner detail, we'll have a look at the side view. From the side view we can see that we have this face which is recessed inwards. If we have a look at our gear face, this entire circular section is recessed on both sides, and then we have these 4 holes that are cut through the gear body. We only need to represent these holes because they are the only ones on the cutting plane that will be seen, so we can ignore any information regarding these 2 holes here. So what I'm going to do is I'm going to project across from our side view again, and we'll then measure distances to get depths. So this line here will be for the start of the recess, followed by lines showing the details of the holes cut into the gear body. Over here we will see part of the keyway in the gear as well, represented over here. And then the last hole, as well as the top of our recessed section. We'll then also indicate details with regards to our gear teeth. So in the question it says that you must assume that the cutting plane cuts through the center of the teeth at the top and bottom. So we can assume that we won't see the root diameter of that tooth because we are cutting through a tooth like that. If we were cutting through over here, we would see a solid line here as well as a solid line there. But what we will indicate on here is a dotted line for the pitch circle diameter of our gear. We'll then measure the width of that recess of our side view, and it's 2 millimeters. So we can mark off 2 millimeters from there as well as 2 millimeters from that side. I'm going to put a construction line straight up on either side and then fill in the detail for that recess on either side. And then finally we'll include the detail for all of our holes. And then the last part to complete is the sectioning of that side view. And then with the sectioning complete, we'll just draw in the center lines for our holes. Which we can just project across from our side view once again. Okay, the next part of this drawing that needs to be completed is representation of the pinion itself, where we'll basically be drawing this body to half scale above our gear with the specified distance between gear centers. The distance between centers that we calculated in the previous example was 126.9. So as we're drawing this to half scale, the distance between centers would need to be 63.5 millimeters. So we'll just measure off 63.5 from the center of our given gear to get the center of our pinion. So the center of our pinion will be in that position. Now, what we know about meshing gears, we can use to now construct the root, outer, and pitch circle diameter for our pinion gear without having to remeasure off, provided we've accurately drawn them on our gear system. So to get the outer diameter, it'll match up with the root diameter. The pitch circle diameter will match up with the pitch circle diameter of our gear set. And the outer diameter of our gear will match up with the inner diameter or the root diameter of our pinion. With all of the relevant diameters for the gear teeth now represented, we will begin to draw the body of the gear in. Now, because the gear ratio is 2:1, it's safe to assume that anything that we measure off on our main gear will be half the size on our pinion. So when we measure off this body diameter, we get 64 millimeters in diameter. So we'll be looking at a 32 millimeter diameter circle. Luckily, on our circle template, we do have a 32 millimeter diameter. So we'll just construct our horizontal center line, and then we'll use our circle template to create the rest of the drawing. So we then align our 32 millimeter circle template with our horizontal center line as well as our vertical center line, and we can draw in that section of our gear. We then can represent the center circle, or the circle on which the shaft will be mounted, which is 10 millimeters, and that'll be a 5 millimeter circle that we need to draw there, but remembering that we do have the keyway at the top, so we'll leave a space, and we'll just check our keyway dimension here is 3 millimeters, so we'll go for 1.5 millimeters in this case. Then to represent the circles, we just need to determine where their centers are positioned. And we can see that we're looking at 18 millimeters from the center line all around. So here we'll do 9 millimeters. for the centers of our circle. We'll just draw in those horizontal and vertical center lines so that we can position our circle templates to draw in the circles. And now the diameters of these are 17. Just double check. We're going to be looking at 16 millimeters, so we'll use 8 millimeter circles on our pinion. Just line up the circle template with our horizontal and vertical center lines. We could also do this with a compass, but it's a lot easier using the circle template as well as a lot faster. And there we have our completed question with our pinion represented with all the relevant diameters to represent the gear teeth, as well as our sectional side view for our gear.